Picture this. You are in a crowded grocery store, and suddenly your child collapses onto the floor, screaming at the top of their lungs because you bought the blue cup instead of the red one. Every eye is on you. You feel the heat rising in your chest, the familiar wave of frustration and embarrassment. But what if this moment isn't about bad behavior at all? What if we've been looking at this entirely wrong? Today, we are going to look deep inside the human brain to understand the real science of toddler tantrums. Behind the screaming and the tears lies an incredible, rapidly developing biological marvel. A tantrum is not a calculated plot to ruin your day. It is actually a vital developmental milestone of a young brain doing exactly what it was designed to do under extreme stress. When we look at this through the lens of neuroscience, we begin to see a beautiful, complex system trying to find its balance in a world that feels completely overwhelming. As parents, we often tell ourselves stories to make sense of the chaos. We think, she's just being dramatic, or he is trying to manipulate me to get his way, or she's doing this purely for attention. These myths are incredibly common, but they are completely unsupported by neuroscience. Toddlers simply do not possess the complex brain architecture required to plan and execute sophisticated psychological manipulation. Their outbursts are raw, unfiltered survival responses. In a high-stress household, when a tantrum erupts, our own stress levels skyrocket. The ticking clock, the messy room, and the social pressure combine to create a perfect storm of anxiety. When we view their meltdown as a personal attack or a behavioral failure, our immediate reaction is to control, suppress, or punish. But this traditional approach fails to address the underlying neurological storm raging inside the child's head. When we yell, demand immediate obedience, or banish a screaming child to their room, we are trying to use logic and authority on a brain that is physically incapable of processing either. Threatening punishments or demanding they calm down only increases their sense of danger. It activates their defense mechanisms even further, turning a short emotional release into a prolonged, agonizing power struggle that leaves everyone exhausted. To understand why these traditional discipline methods fail so spectacularly, we have to step away from the behavioral surface and look deep inside. We must journey past the tears and the physical struggle, zooming into the microscopic pathways of the human brain. Here, we find two distinct systems locked in a powerful tug-of-war that dictates every single emotional response. Deep within the temporal lobes of the brain lies a tiny, almond-shaped structure called the amygdala. Think of the amygdala as the brain's ultimate emotional alarm system and threat detector. It is ancient, highly efficient, and constantly scanning the environment for danger. In a young child, this alarm system is fully operational from birth, ready to sound the siren at a moment's notice. When the amygdala detects a threat, it doesn't stop to analyze the situation logically. It instantly triggers the primal fight-or-flight survival response. It prepares the body to battle a predator or flee from danger. For a toddler, a broken cookie or a transition from playtime to bedtime can register as a life-or-death crisis, sending the amygdala into an absolute frenzy of activity. Once the alarm is triggered, the amygdala commands the endocrine system to flood the body with powerful stress hormones, primarily cortisol and adrenaline. This chemical wave is sudden and overwhelming. It surges through the child's tiny bloodstream, instantly altering their physical state and hijacking their entire nervous system before they even realize what is happening. This chemical flood produces immediate, intense physical symptoms. Their heart rate spikes, their breathing becomes shallow and rapid, their muscles tense up, and their body temperature rises. The physical discomfort of this state is incredibly distressing for a child, which explains why they scream, throw themselves to the floor, or physically thrash around. They are reacting to an internal physical storm. But why does a minor trigger, like a spilled cup of milk or a broken crayon, cause such an extreme reaction? Because to an underdeveloped amygdala, there is no scale of importance. A minor inconvenience is processed with the exact same urgency as a physical threat. The brain's threat detection system goes into overdrive, treating a lost toy as an absolute, existential emergency. In a mature adult brain, the amygdala's emotional alarm is kept in check by the prefrontal cortex. Located right behind your forehead, this is the logical brain. It is responsible for reasoning, planning, impulse control, language, and self-regulation. It is the wise leader that analyzes the situation and says, hey, it's just a blue cup. It's not a real emergency. Renowned psychiatrist Dr. Daniel Siegel calls what happens next flipping your lid. When the emotional brain, the amygdala, becomes highly active, it completely disconnects from the logical prefrontal cortex. The physical pathways connecting the two parts of the brain are temporarily severed. The wise leader is kicked out of the room, leaving the emotional alarm system in absolute control of the entire body. This is why words are completely useless during a meltdown. When a child has flipped their lid, their language processing centers in the prefrontal cortex are offline. When you say, "Stop crying," or "calm down," your words sound like muffled, meaningless static to their brain. They literally cannot process your logical explanations or commands because the hardware required to do so is temporarily shut down. Instead of hearing your logic, the child is experiencing intense sensory overload. The lights seem brighter, sounds are louder, and their own internal physical sensations are terrifying. Their brain is receiving too much data and has no way to filter it. Trying to reason with them during this state is like trying to install a software update on a computer while it is currently on fire. What we see is a total communication breakdown. The parent is trying to communicate from their logical prefrontal cortex to the child's logical brain. But the child's logical brain isn't home. You are speaking a language they physically cannot access in that moment. To bridge this massive gap, we must change our approach entirely, shifting from words to neurobiology. Why is this system so fragile in children? The answer lies in development. A child's prefrontal cortex is highly underdeveloped at birth. If the brain were a house, the emotional downstairs brain is fully built and fully furnished, while the logical upstairs brain is still just a collection of wooden beams and wet cement, completely exposed to the elements. Building this logical upstairs brain is a long, slow process. In fact, neuroscience shows us that the prefrontal cortex does not reach full maturity until around age 25. Let that sink in. A toddler has only had a couple of years to start building a structure that takes a quarter of a century to complete. Expecting them to regulate their emotions is like expecting them to drive a car. If we compare the neural pathways of an adult brain to a highly efficient multi-lane highway system, the toddler's brain is more like a simple winding dirt road. The connections between the emotional amygdala and the logical prefrontal cortex are weak, slow, and easily washed away by a storm of emotion. It takes years of practice and biological growth to pave those roads into highways. Every single time we help a child calm down, we are helping them build those neural pathways. Through a process called synaptic pruning and myelination, the pathways that are used repeatedly become stronger and faster. By providing a calm, supportive response during a tantrum, We are literally helping them lay down the physical infrastructure for future emotional regulation and self-control. From an evolutionary perspective, tantrums actually served a vital purpose. For a helpless young human in the wild, signaling extreme distress loudly and immediately was a survival mechanism to ensure adult protection. It was a primitive distress beacon designed to bring caregivers close. Understanding this history helps us view tantrums not as a behavioral defect, but as an ancient survival strategy. So how do smart parents apply this neuroscience in the heat of the moment? The golden rule is simple: connect before you correct. You cannot teach a lesson, explain why their behavior is wrong, or enforce rules while their lid is flipped. Your first and only goal during a tantrum is to help them close their lid, which is achieved through a powerful process called co-regulation. Co-regulation means using your calm, mature nervous system to soothe their chaotic, overloaded nervous system. Because children mirror our emotional states, your calm presence acts as an external prefrontal cortex for them. By breathing deeply, lowering your voice, and offering a gentle, quiet presence, you signal to their amygdala that they are safe, slowly turning off their internal alarm system. Only when the storm has fully passed and their logical brain is back online, which might be hours later, can you talk about what happened. This is when correction can finally occur. When they are calm, their brain is receptive to learning, and you can gently teach them better ways to express their big feelings. This approach turns a frustrating tantrum into a powerful teaching moment. The next time your child has a meltdown, try to remember, they aren't giving you a hard time. They are having a hard time. Their brain is simply doing its best to grow. If you found this scientific perspective helpful, subscribe to ParentLab for more science-backed insights into your child's developing mind. Let's build stronger connections, one brain pathway at a time.